So 2.1 is using inductive reasoning to make conjunctures. We're going to go over what inductive reasoning is and conjunctures in the lesson. So the objective is to use inductive reasoning to identify patterns and make conjunctures, and to find counterexamples to disprove conjunctures. So vocabs: inductive reasoning, conjuncture, and counterexample.
My bad. I didn't do that.
So we're going to look at this pattern and find the next item in the pattern. So we have January, March, and May. What would the next? July, right? Because it goes every other month. So the next one would be July. Let's look at the next pattern. Find the next item in the pattern. 7, 14, 21, 28. What would the next one be? 35. Because we're adding 7 to each number in the pattern, so 28 plus 7 would be 35. Okay, find the next item in the pattern. So we have a triangle that's pointing up, a triangle that's pointing to your right, then a triangle that's pointing down.
Triangle pointing to the left.
So then we'd have a triangle pointing left. So it would look like this. I guess that would be right if you're looking at the board. But you see how it goes this way, down, up. Goes in counterclockwise. Find the next item in the pattern. We have 0.4, 0.04, 0.004, right?
0.0004.
0.0004. So we're adding a 0 before the 4 and after the decimal in each one.
Miss, what does it mean by Q1?
Quarter one. When several examples form a pattern, you assume that the pattern will continue. You are applying inductive reasoning. So this is what we've been doing, inductive reasoning, by assuming that the pattern continues and finding the next number. So inductive reasoning is the process of reasoning that a rule or statement is true because specific cases are true. You may use inductive reasoning to draw a conclusion from a pattern. A statement you believe to be true based on inductive reasoning is called a conjuncture. So we're just going to do more examples involving those on the next slides. So complete the conjuncture. The sum of two positive numbers is blank. Name a positive number. Any number. 2. Ryan says 10. So the sum would mean we're adding them. So it's 2 plus 10.
12.
What's another positive number?
4.
What's another positive number?
5.
8.
Oh shoot.
What's 4 plus 5?
9.
What's another positive number?
6.
And another one?
11.
1.
What's 6 plus 11?
17.
Yeah.
What's a positive number, bud?
It is.
Yeah, let's go.
Wait, what's a positive number?
So all of these sums are positive. So the sum of two positive numbers is
Positive.
positive. So complete the conjuncture. The number of lines formed by 4 points, no 3 of which are collinear, is... So let's have 4 points. 1, 2, 3, 4. How many lines can we form by these 4 points?
Oh no, we can make 6.
6. Right, we have a line here, another one there, another one there, another one there. We have a diagonal line and a diagonal line. So it's 6 lines. So the number of lines formed by 4 points is 6, right? It's just asking for the number of lines. So that would be 6. So complete the conjuncture. The product of two odd numbers is, so what's an odd number? Any odd number.
1.
3, And what's another odd number?
1.
17.
5. So what does it mean to do the product?
No, multiply.
Multiply.
Yes, smart.
So when you're doing the product, you multiply. So what's 3 times 5?
8.
15.
15.
Oh,
What's another odd number?
1.
What's another odd number?
8. 7.
11.
7, 11.
So what's 1 times 11?
11.
What's another odd number?
9.
Alright, tasty.
What's 9 times 7?
17. Oh, wait.
9 times 7.
Hold up, I got this.
63.
63.
Get that off the rip.
What do all 3 of these numbers have in common?
Odd.
They're all odd. So the product of 2 odd numbers is
Odd number.
odd.
Oh.
Why do they call it an odd number?
Slide. The cloud of water leaving a whale's blowhole when it exhales is called its blow. A biologist observed blue whales' blows of 25 feet, 29 feet, 27 feet, and 24 feet. Another biologist recorded humpback whales' blows of 8 feet, 7 feet, 8 feet, and 9 feet. Make a conjuncture based on the data. So what can we tell already about the height of the blue whale blows?
It's really high.
They're odd,
So they're high
but they're odd.
compared to the height of the humpback whale's blows. Even if we look at the lowest number of the blue whale blows, 24, it's still a lot higher than the highest number of the humpback whale blows. So what can we make a conjuncture? What would our conjuncture be based on this data? Sir.
Blue whale blows are higher than.
So blue whale blows are higher than the height of humpback whale's blows.
That's the answer.
That's the answer. That's all we're finding.
When they're saying like,
Yo.
no, I'm saying like, I don't understand what it is.
So we're taking the information that's given to us and making a conjuncture, which we're making a true statement about the information that was given.
So this is math.
It's inductive reasoning. So yes.
I have a chance now. I'm ready for that test.
Make a conjuncture about the lengths of male and female whales based on the data. So we have the length of female whales.
Wouldn't we have to average them all?
We could.
That's a lot of work though.
And we have the length of male whales. If we look at it,
I mean, you could just tell about female.
well, let's look at the first one. What's higher, 49 or 47?
49.
49. What's higher, 51 or 45?
55.
What?
I mean,
51.
51 or 45? What's higher, 50 or 44? 50.
Julie, you really
What's higher, 48 or 46?
40.
What's higher, 51 or 48? And this one's the only one where the male is higher. So we could say that
Mostly females are bigger.
how many times? There was 6 studies, so we could say 5 out of 6 times females will be longer. So on average, female whales are longer than male whales. To show that a conjuncture is always true, you must prove it. To show that a conjuncture is false, you have to find only one example in which the conjuncture is not true. This case is called a counterexample. A counterexample can be a drawing, a statement, or a number. So when we're proving that something is false, all we need is one example to show that it's false. So this is going to give us a conjuncture, and we have to prove it to be false by giving a counterexample. So inductive reasoning, step 1 would be to look for a pattern. That's what we did on the first couple slides. Step 2 would be to make a conjuncture. And then step 3 would be to prove the conjuncture. So when we prove a conjuncture, we prove it to be true. Or find a counterexample, which just proves it to be false. So show that the conjuncture is false by finding a counterexample. So this is our conjuncture. Now we have to find a counterexample that proves this to be false. So for every integer n cubed is positive. So what's an integer?
Negative and positive.
Negative and positive numbers. So give me an example of an integer, Adam. Negative 3. So if we have negative 3, what would n cubed be? So what's negative 3 times negative 3?
Negative 27.
Negative 3 times negative 3. 9. What's 9 times negative 3? Negative 27. Is negative 27 positive?
No.
No. So this proves it to be false. And this would be our counterexample. So when n is equal to negative 3, it proves it to be false. So all you'd have to put is the counterexample is n is equal to negative 3. Yes. Yes.
For some reason, I keep on thinking when this is positive, it means even.
Show that the conjuncture is false by finding a counterexample. 2 complementary angles are not congruent. So we need 2 complementary angles. What makes an angle complementary?
90 degrees.
They add to 90 degrees. So we need 2 angles that add to 90 degrees that are congruent to prove this to be false. So 2 angles that add to 90.
45 and 45.
45 and 45. So if we had 2 angles that are 45 and 45, yes. So 45 are 2 complementary angles that are congruent. So this would prove it to be false. And this would be our counterexample.
So we have to prove it to be false by finding something.
All you need is 1 counterexample that proves it to be false. So show that the conjuncture is false by finding a counterexample. The monthly high temperature in Abilene is never below 90 degrees Fahrenheit for 2 months in a row. So what we need to do is see that it is below 90 degrees for 2 months in a row. Right, January and February. It's below 90 degrees for 2 months in a row, so this would prove it to be false.
Will this be on the test?
Yes.
Do you write false if it's like...
If it asks if it's true or false, you would say false, and then you would have to give the counterexample, which you would just write January and February.
Alright.
Show that the conjuncture is false by finding a counterexample. For any real number x, x squared is greater than or equal to x. Casey.
1.
So let's have x equal 1. What's x squared?
1.
So 1 is greater than or equal to x, which is 1. So this is true, right? Because
Yeah.
it's equal to.
You have to make a counterexample, so you.
So we need something that shows that it's false. Okay. So what's another number? Now that we know what real numbers are. Anyone come up with an example to prove this to be false?
It's impossible.
So I could say -1, right?
So let's say -1. So x is equal to -1.
Then
So what is -1 squared?
1.
1.
So it would mean that 1 is actually greater than negative.
But isn't 1 greater than -1?
Yeah.
So this proves it true also.
Oh, I thought
We need to see other guys.
Wait, we need to make it false?
We need to make it false. And we need a counterexample. Julian had a good idea.
Me?
Yeah.
What'd you say? Which one is false? What'd you say?
Julie. Good idea.
Hold on. 0.
Let's do 0. What's 0 squared?
It's equal.
It's equal.
So that isn't a good idea.
So it's not a good, well, I mean, it's a good idea, but just wrong.
It's impossible. You can't find it.
Is there an example that you know?
Yes.
Oh my god.
Oh yeah, it's possible. Big brain.
Can't be a negative, right?
We just tried a negative. What if we had x is equal to 1/2?
Because
So what's 1/2 squared?
3.
1/4
1/2 times 1/2
is
is
1/4.
1/4.
Let's go. I'm smart.
I was thinking of 1 point.
What's 1/4? Is it greater than or equal to 1/2?
Less than.
It's less than.
Let's go.
So this would be less than or equal to. So this proves it false. And our counterexample would be 1/2.
Was that your example?
Like that on this.
There could be.
Was that your example?
This was the.
No, but like the one
Mhm.
the one I don't know.
1/4?
Yeah.
So you do it in fractions.
Any fraction. You could do it any number between 0 and 1. So any fraction. Sure.
I just came up with that, okay?
Show that the conjuncture is false by finding a counterexample. Supplementary angles that are adjacent. What are supplementary angles?
That add up to 180.
Two angles that add to 180. What are adjacent angles?
Next to each other.
Next to each other, so they're touching. They share a side. So we need two supplementary angles, so two angles that add up to 180 that don't share a side. Right? Because we're trying to prove this to be false. So if we had an angle here that was 50 degrees, what would its supplement be?
130.
130. Are these two angles adjacent? No, they don't share a side. They're not touching.
Oh,
So we prove this to be false. And this would be our counterexample. Okay, last slide.
Yay.
Find the next item in each pattern. So let's look at number 1. What would the next number be?
0.0007.
0.0007. So you would just add a 0 in between the decimal and the 7. What about this one? We have an arrow pointing to the right, an arrow down, an arrow pointing to the left. Arrow up. Right, so we have an arrow pointing this way, then we go down, then we go side, then we go up. So we're just rotating 90 degrees each time. Let's look at number 3. The quotient of two negative numbers is a positive number.
True.
What's a quotient?
Division, when you're dividing.
Okay, so what's a negative number?
2.
-2.
And what's another negative number?
-4.
-1. What's 2 divided by -1?
+1. 2. +2.
+2. What's another negative number?
-4.
-4. What's another one?
-5.
-5. What's -4 divided by -5?
You can't do that.
Well, it's 4/5.
Oh, it is.
Right? Because a negative divided by a negative is positive. So the quotient of two negative numbers is a positive number. This would be true.
But the next one isn't true, right?
Okay, let's look at the next one. Every prime number is odd.
2.
Right. 2 is prime. What's a prime number?
It's and two multiples. Yeah. Like Like 2 5. No, a prime number
Like
can only,
7 is
it's
a
like
prime
1 and
number.
2. Like,
What is a
another
prime
example
number?
would be like 1 and 3.
A prime number is a number that can't be multiplied by 2 other numbers to get that number.
Yes.
Okay.
You can multiply.
So a number that's only divisible by itself and 1.
7.
Like 3.
But
Yeah, so 3. So 2, 1, 2, 3, 4. Well, 4 is not. 5, 7,
9.
11.
No, 9 can be divided by 9. I don't
But for this one, what's our counterexample? 2, because that one's even. So this would be false, and 2 would be our counterexample. Mm-hmm.
What?
Wow, guys.
That's only even number.
In the prime,
That's a prime number.
well,
So 2 supplementary angles
keep going.
are not congruent. So what are 2 supplementary angles?
180.
2 angles that add to 180. Can we have 2 supplementary angles be congruent?
Yeah.
What would they be?
95.
90
Oh, 99.
plus 90 is equal to 180. So this would be false. And that's our counterexample. All right, last one. The square of an odd integer is odd. So if we had an odd integer,
Negative 2.
-2 is not odd.
Oh, wait.
Negative
Oh, sorry,
sign.
3.
Let's look at 3.
I thought we
What's
were
3 squared?
3. No, 9.
9. What about, what's another odd integer?
10. I mean 11. My bad.
Let's do 5. What's 5 squared?
It's true. It's true.
25. Let's look at 11. What's 11 squared?
121.
121. What do all these numbers have in common?
Odd numbers.
They're odd. Can we find any square of an odd integer that's not odd?
No.
So this one would be true.
Yeah.